Good afternoon. It's a real pleasure for me to introduce some work done inside the project group on reference system for somatic cell counting. Some of you knows this project, and I'm going to give you some general information of this project. The project group on reference system for somatic cell counting is under the aegis of ICAR and IDF. It's composed by 28 members, very active from 19 countries and for the 4 continents. Our main goal is to reach equivalence in somatic cell counting. The model that we are going to show you could be also applied to the other parameters. So why we have started from the somatic cell counting? For sure, this parameter has a great economical impact in the dairy sector because we perform in the world a lot of analysis. He has a great impact in farm management because he's involved in the health status of udder, and is a parameter that is involved in the EU regulation for milk payment, and also is a sensible parameter for breeding program and used in the breeding programs. We have heard some presentation this morning also on it. Also, the global dairy market required that the results of our analysis are comparable between countries and between labs. We would like to have a three-dimensional view of this. So usually we use this as a slogan: everywhere, every method, and every time, our data analysis should be comparable. So this is our goal, and what we would like to reach with this project is to really realize harmonization in practice, not only in theory. How to realize this project? From the beginning, the project group agreed that we would like to collect information from the real analytical situation. We have to identify the local analytical system. We would like to identify the tools that we are using in our daily life, like reference material, like the type of reference material, how we use these products, and what type of proficiency tests we are taking part. So if we collect this information and we use in the right way, for example, we establish the competence of the data that we are collecting, we can create a processing model. We are approaching to it. The statisticians in our group are proposing a probabilistic model. And we would like to announce a pilot study to see if the system works well and is functioning. In this presentation, we will focalize on how we have collected this basic information. They are really important to building up our project. How to define analytical system? This is very important. Analytical system doesn't mean necessarily a national system. Analytical system, I like to imagine a group of labs that are contributing and collaborate each other, for example, using the same quality assurance tools, like the same reference material, or taking part in the same proficiency testing scheme, or we have seen there are defined also local analytical system, a group of labs that are just collated each other because they use the same procedure, or they use one pilot sample that's circulating among them. So we have different situations. What we would like with this project is to throw a bottom-up approach, considering all this analytical situation, to collate this system together with an international neutral platform that we call reference system for somatic cell counting. How to collect the data? The best idea was to prepare a questionnaire and to send out this questionnaire, and the first was launched in 2010 and was dedicated for the reference material providers. The information from this questionnaire was we have collected from 13 providers, 11 from Europe and 2 from United States. And what's that, the feedback of this first questionnaire. 3 important steps. We have different metrics. We have different range. The provider prepared different set in terms of range and the level provided of sample, and different characterization process. Regarding the matrix, we have raw milk, we have heat-treated milk, natural cell, external cell, synthetic particles, and these reference material are used in different way. And interesting, we will see later that some laboratory use more than one reference material, or they don't use reference material. And regarding the range is very important. We have a range that some provider provide a range from 100,000 to 400,000 of somatic cell, and other provider from 100 to 2 million, more or less. So can you imagine that if we want to check the calibration of our instrument is different if we are using so different tools? And the third level of information that we have received is the characterization process. Some providers use reference method, perform only one lab, or perform in only one lab with more than one technicians. Some using only routine methods. Some use a combination of routine and reference method. And some other providers use the proficiency testing scheme. I mean, they prepare the products, they are characterize this reference material only using the proficiency testing scheme on the routine method, and they use the CNIAT values as reference values. So the situation is quite different. From this information, we would like to collect the best information and to provide some information for the participants' labs in the project. From these results, the group provided 2 important documents. One document described the minimum requirement that a reference material has to do to check the instrument that analyzes somatic cell counting. And the second document is a practical instruction on how to prepare the reference material. This document can be used to prepare also an internal reference material, not necessarily a golden standard, but the basic concept, for example, the range, the type of matrix, is essential that we use always the same, all the labs use the same scheme. The concept is valid also for the proficiency testing scheme, because frequently we use to characterize the reference material through the proficiency testing scheme. So the two quality assurance tools are very much interconnected each other. The second questionnaire was dedicated for the routine labs. The answer was really great. The group was very happy about the feedback of the answer. We have received more than 200 information from the labs that describing 225 instruments in 36 countries from the 5 continents. The figures of for the success of this questionnaire was that first of all was translated in 6 languages, and there was some very synthetic documentation as accompanying paper to the questionnaire, and we have identified the key person in different area of the world. And this was very important because this key person, these distributors, send to the routine labs the questionnaire giving again the right information. So the answer that we have received really was a real picture of the laboratory. The technicians fulfilled the questionnaire really without to think some problem or about anonymous data treatment. Just fill the questionnaire, and we received a very interesting picture on how the analytics is applied for somatic cell in the different labs. So the area that we covered is from America, Canada, South America, South Africa, Tunisia, large answer from Europe, and also from Asia, Israel and Japan, and from Oceania, New Zealand. This is the percentile of the answer that we have received. You can see that you can see that the main area number came from Europe. Also, America, North America gave a great contribute, and it described very well how one system works, and also from other countries. This is the questionnaire. Don't pay attention to the question, to each question, just to focalize the attention to the first part of the questionnaire. We would like to receive a feedback about the instrument that we are using, the technique that we are using, what type of check we do when we calibrate our instrument, if we move the calibration, if we have the limit to check the accuracy, and what type of reference material we used. And the third part of the questionnaire deal with the participating in different PT scheme, local scheme or more than one. The technologies used is well known, mainly is a flow cytometry, displaying on disk. Some labs is using, but is quite older technology, and appeared on the market about 10 years ago, the charge couple device, and it is used in some different area of the market. And also we have identified 5 manufacturers. And interesting was this, from this second questionnaire, we have received information on other providers that we didn't know with the first questionnaire. We have identified 15 providers instead of 11 in Europe, 4 in United States, and 1 in Japan, and 1 in New Zealand. Of course, Japan and New Zealand, how to define that reference material is not an internal reference material, but is a national reference material. So it's clear that that countries is working in one organized system. And if this system is interconnected with another one, we have a lot of useful information. Calibration procedure, 84% of the answer said yes, I calibrate my instrument, and 60% said no. We have investigated of that percentage, and it seems that they use a proficiency testing scheme, or, as I said before, one pilot sample to check with other labs if they are aligned or not. And interesting was also this question regarding the type of reference material that you use. We can see that mainly they use natural cell, but we have also many labs that use a combination of different reference material. And we have focalized the attention to this laboratory because they are creating really a practical comparison in their lab. And 6% answered that they don't use any type of reference material. 80% seems they are conform to the indication that we have in an ISO 13336, part 2, where it is stated that you should check your calibration 1 time per month. So another question was, what type of regression slope you have? Only 38% answered. And this was interesting because it's not clear for some labs the difference between calibration check and adjustment. So this is a great number of labs, 62% that didn't answer. Apparently from the question seems that they don't fix a limit of the accuracy. But probably they have, but they didn't manage daily. Just they do a comparison and they don't move the slope of the instrument. So about, from this question, from 38% of the labs that answer yes, we check the slope, 40% has a percentage of accept a bias of from 0 and 5%. But we have to check this answer with the range that they check. And 26% accept a bias from 5 to 10%. And again, we have to see if they check a set of calibration from 0 to 2 million or from 200, 400. So everything is relative. About the first information that we have collected about the PT scheme participating, 11 labs don't participate, 104 participate in the national PT scheme, 19 only in the international PT scheme, and 72 labs participate in both schemes. So these labs really are interconnected. And we have calculated, and we show you later, about more than 400 interconnection in the world. So how many samples travel in the world? Eh? Now we will analyze the situation continent by continent. We have in South America, in Argentina, that is connected, for example, with Brazil and Bolivia. And this is an analytical system. They use their reference material projects and the organized PT scheme. We have Canada, and we have checked that there is one laboratory in Canada that is interconnected with the United States. This is the answer that we have received. Probably there are more than one lab that isn't connected with the United States, but from the answer that we have received, we know that there is one lab that is interconnected, so we could zoom and pay attention to these two labs, and many information from United States. So we have, for example, 3 local systems, and 2 of these systems are interconnected. How the America is interconnected with the rest of the world? Through Argentina, they participate in European PT scheme. Asia, we have Israel. That is very interesting information we have collected from here, because they taking part in 2 European PT schemes, and they provide the data to the ICOR reference laboratory network. Also, we have Japan that is isolated apparently, but he taking part in European PT scheme. So also Japan is connected. 2 local systems connected with European system. Oceania focalized the attention on the New Zealand that is interconnected too with the PT provider. Africa, South Africa, and Tunisia through PT scheme and reference material. This is a typical example from the questionnaire and from some questions that we have put to this laboratory. We have 2 systems in the same continent. They are not interconnected each other, but both of them are interconnected to the same PT scheme. So if they want, and if the project in the future will be functioning, they could have a great feedback, because they are taking part in the same population. And we have 2 local systems connected with the same PT. Europe. As I told you before, 70% of the answer came from Europe, and we have a lot of traffic here. Huh? Seems like a air flight map. You see from many countries. Many of these countries give the data to the ICOR reference lab network, but to take the right information and to reach our final destination, we have to find the right connection of this flight. So we have to study well. So this picture is nice, but what we like to notice that is the ICOR on Europe has a very central position, and this is strategic. It's a neutral international platform that can collect a lot of important information from the European labs, and will be not so difficult to interconnect it. We know that from Israel also there is a connection, so Asia starting to participating, and we could involve also other continents. This is our expectation. All these data were plotted on the table. I don't pretend that you can understand, just to give an idea how many data we have tried to plot it. And from this scheme, we have identified 21 labs that are very interesting if they want to give us information, because they use more than one quality assurance tools from different providers, and they taking part in different PT schemes. So their data will be very strategic for us to develop with a bottom-up approach to develop our project. 4 countries seems a little bit isolated, and so again, if the project group will be advertised in the right way, these 4 countries will have a great advantages from it. To sum up, we are collecting data. We have to develop a statistical model of this data. As I told you, again, we are approaching to a probabilistic statistical model, and to try to develop a pilot study to see if the system is effectiveness is enough robust, and he can work in the real life, can work in real life. I show you the bottom-up approach. So starting from the bottom, we have collect information, and what's the feedback of this project? Collect data from the reference lab and from the routine labs. They will contribute to characterize a reference material, that these assigned values will be calculated in the right way and in a standardized way, and the assigned value will be transferred to the national lab that could prepare the reference material according to the procedure that we are going to provide them, and to transfer this calibration to the secondary local system. So this is the traceability that we like to imagine for the future. Of course, it's necessary to establish the competence from the contributing labs and the data that we are going to using. And it's necessary that a coordinator cover this task. So to leave you an imagine of our project, I came from Rome, so for me it was easier, this example. If we are inside the Colosseum, we have a wonderful view. If we are outside, we have a detailed view of our system. We can enlarge the view and understand the context where we are working, and wider, we could arrive to a global view, and the reference system could be the anchor that we would like to offer to the analytical laboratory. So I would like to invite you to follow our development and our project on the IDF and IGAR website, and also some publication. And I would like to thank you in the name of the project group. Thank you very much.